All right, guys, 1.3, exponential functions. So, basic exponential function is some number to the x power where x is the exponent. Got it? So, for example, if I did f of x equals 2 to the x, my graph would show exponential growth. It would look like that. If my function was 0.5 to the x, where my base is some number between 0 and 1, this is exponential decay. So it starts out high and then gets lower. Hopefully you remember that from Algebra 1 and Algebra 2. With that came rules of exponents. So first rule, if you guys remember, is if I have a to the x times a to the y, if I'm multiplying with the same base, I add the exponents. You guys all remember that? If I'm dividing with the same base, I subtract the exponents. If I'm going from an exponent to an exponent, I am multiplying the exponents. It's like distributive property. If I have two things getting multiplied, but they have the same exponent, I can just condense it and just say that's going to be a times b to the x. Or, same thing with division, except the other way, is if I divide and say, hey, they're both to the x, that means each one can separately be to the x power. Got it? So, let's do an example. Okay. Oh, wait, there's other thing I have to remember. Oh, sorry, my bad. Other rules. If I did 1 over a, that's the same as a to the negative 1. Remember, negative exponent is when it's really there. So, for example, if I did 1 over a to the third, that's really a to the negative 3. Other rules you might remember is that the square root of a, square root is really to the 1/2 power. So cube root would really be to the 1/3 power. I know I did all this with my Algebra 2 students last year. I'm very sure Mr. Troy did as well, and Mr. Falau, so you guys should all remember these. All right, now let's do an example. So let's say I want to simplify. This. Now, if you'd like, you can ask Mr. Gorman to pause the video, and you guys can try to simplify this yourselves. See how far you guys get. The answer should have nothing but positive exponents. Then have him press play, and then we can see how I do it. So it's up to you. All right, first things first. I'm going to take this 2 on the outside and multiply it to everything here. And this 3 is going to get multiplied to everything there. So I should have x to the negative 6, y to the 4th, over x to the 12th, y to the 9th. Now I can use my rule where if they're over each other, I'm really subtracting the exponents. So for x, negative 6 minus 12 is negative 18. 4 minus 9 is negative 5. Now remember what I said. Your answer should have nothing but positive exponents. So if I have negative exponents, that means they go downstairs and turn positive. Well, if they go downstairs, what's left at the top? Well, the only thing left is 1, and that is your final answer. So there will be some of those in your exponent work. Other things to remember for exponents would be word problems. I don't know. Let's say we use Stanley's name. Stanley invests $2,300 in a savings account. With 6% interest rate, compounded annually. How long will it take until Stanley's account equals $4,150. All right. Exponential equation. How do I know it's an exponential equation? Because it has an interest rate type problem, and it is compounded annually. That means once a year, the bank is going to add 6% onto Stanley's account balance. $2,300 is going to be our initial point. So now you have to remember our equation here. If you remember this, it's y equals a times 1 plus r to the t power. Why the 1? 1, remember, is 100% plus the 6% you've got. So in our case, our a is our initial starting point is 2,300. 1 plus, you don't do 6%, you do 0.06, because remember you have to change percent into decimals. So it becomes 1.06 to the t power. I'm now saying take this equation and you have to set it equal to $4,150. So $4,150 equals 2,300 times 1.06 to the t. All right, solve for t. We're solving for time, how long it's going to take to do this. First thing, divide both sides by 2,300. This cancels out, and you get 1.804 equaling 1.06 to the t power. Now, you have to remember from Algebra 2, how do we get things out of the exponent? How do I get variables out of the exponent? Well, that's where log comes in. I know how much you guys all loved log. So remember, you've got to log both sides. And what happens is you have log of 1.804 equaling, and the t comes to the front, times log of 1.06. Now you still have to get the t by itself. So you're going to divide by log of 1.06 on both sides. Now look at how I did it in parentheses because of your calculator. You're going to have log parentheses 1.804, close that parentheses, divided by log of 1.06, and you should have gotten t equals 10.129 years. So a little over 10 years. So hopefully it should come back to us. I think a lot of you guys have done this in pre-calc as well. Let's do another type of word problem example you guys will see on your homework. Determine how much time is required for an investment to triple in value if the interest earned at a rate of 5.75% is compounded continuously. What does that mean, compounded continuously? How is that different from our last problem? Our last problem was compounded annually. That means you're only taking that percent once a year. Compounded continuously means it's happening all the time, at this second, at this second, at this second. It's happening all the time. It is continuous. It does not stop. Got it? So anytime you have compounded continuously, you have to use the equation y equals p e to the rt. I know some of the pre-calc teachers like to call this PERT or something like that. Whatever it is, but that's fine. You're going to use e because it is compounded continuously. Remember, e is a number. It's like pi. It's an irrational number. It's like 2.17 blah, 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 blah. All right? P is how much you have when you start. Nowhere in this problem does it show us what we're starting with. So that means I'm going to keep P, but I know that I want it to triple in value at the end, so that means it has to equal 3P at the end. E to the RT, R is still your rate. Got to change that percent to a decimal, so 0.0575 T. So this is what you're going to solve for. All right, so let's solve this. So you have 3P equaling P e to the 0.0575T. Now, some of you guys might be freaking out right now, but because you're like, there's too many variables, too many variables. Well, what happens when I divide both sides by P? Hey, look, they're both gone. So it's really just 3 equals e to the 0.0575T. Now, how do I get rid of e? It's a log, same type of thing, except what we use is the natural log. So then you're going to have the natural log of 3 equaling, here natural log and e cancel out, and you have 0.0575T. And then you can divide both sides by 0.0575. That cancels out, and you get T equals 19.106. So it's about a little over 19 years. All right, homework on this. This is assignment number 3. Today should be the 15th. Page 26. This is section 1.3. 1 through 39 odd, just those ones. Tomorrow, you're getting a day to work on all your homework. Come up with any questions, give them to Mr. Gorman, or you can email them to me. And then by next week, I'll try to create a video going over your questions. That's it. Since I won't talk to you guys again until Monday, have a good weekend.